Hello everyone. So in differential equation, a linear differential equation especially with constant coefficient, we have seen that there are several methods for finding the particular integral. We talked about linear D operator problems, some techniques for finding the particular integral, then variation of parameters method, and now the method of undetermined coefficients. So if we are talking about a linear differential equation, then the differential equation will be of the type 1, where px and qx may be functions of x or constants. And if you are talking about a differential equation with constant coefficient, then p and q must be a constant. Rx is a function of x. For those cases in which the complete primitive of the reduced equation d2y dx2 plus px dy dx plus qx y equal to 0, that is rx has to be 0 in the reduced equation, is known. In other words, the complementary function of 1 is already known. So you can get the complementary function of 1, and that is the complete primitive of 2 reduced equation by the auxiliary equation. You are writing the auxiliary equation, the roots. If roots are real and equal, you can real and unequal, real and equal, and imaginary. So these are the three possibilities. So we know if ypx is any particular solution of 1, then the complete primitive of 1 is y equal to cf plus ypx. This is the complete primitive. But the question is, how do we find yp? How do we find yp? So the method of undetermined coefficients is a procedure to find yp when in 1 px and qs are just constants, say a and b, and rx is an exponential, a sine or cosine, a polynomial, or some combinations of such functions. So Rx can be exponential, a sine function, cosine function, polynomial, or is the combination of exponential, polynomial, sine with the polynomial, exponential with the sine, cosine, this type of functions. So that is the method of undetermined coefficient. So let's have the concept of that method. For example, suppose you are considering the equation number 3, that is d2y dx2 plus a dy dx plus by equal to e to the power lambda x, where a and b are constants. Instead of the function of x, we'll take a and b, the coefficients are the constants. Now when we differentiate e to the power lambda x, we get the same function, right? Because derivative of the exponential function is exponential function with some numerical coefficient. It is therefore justified to guess that ypx equal to a e to the power lambda x, where a is an unknown. Then this type of yp might be a particular solution of 3. Here a is the undetermined coefficient to be chosen that 4 satisfies equation 3. Right? We then get, if you are substituting in 3, then the double derivative of e to the power a e to the power lambda x will be a lambda square e to the power lambda x. First derivative of a e to the power lambda x will be a lambda b e to the power lambda x. And the last one is b e to the power lambda x. So this type of, you will arrive of this type of equation. And e to the power lambda x not equal to 0. So you get a equal to 1 by lambda square plus a lambda plus b, except when denominator is 0. This is the value of a except when the denominator is 0. Right? In this exceptional case, lambda is a root of the auxiliary equation. Right? Lambda is a root of the auxiliary equation. Okay? So, if lambda is a root of the auxiliary equation, m square plus am plus b equal to 0, this is the auxiliary equation. Right? And then 4 reduces to the left hand sides of 3. to 0, and it cannot possibly satisfy 3 as it stands with the right hand side different from 0. So if lambda is a root of the equation, auxiliary equation, then your left hand side must be 0, but your right hand side, look at the right hand side, it cannot be 0. It is so left hand side is not equal to right hand side. So your particular, in this case, you have to take the particular integral as ypx equal to ax e to the power lambda x. Now it will satisfy the equation. I substitute that right solution. So it will satisfy the equation. So you have a extra x multiple. Now substituting in 5 and 3, we get a. So you will substitute similarly. A lambda square, a lambda plus bx e to the power lambda x plus a into twice lambda plus a e to the power lambda x and equal to e to the power lambda x. The expression, this will be 0 since we have assumed that lambda is a root of the auxiliary equation. So this must be 0, right? So you have a equal to 1 by 2 lambda plus a, provided that a should not be minus 2 lambda except when a equal to minus 2 lambda, or when lambda is a double root of the auxiliary equation, right? So in this last exceptional case, that is when lambda is a double root of the auxiliary equation, yp can be taken as ax squared e to the power lambda x. And again you are substituting in 3 the given equation, and lambda is a double root of this. So we have this is equal to 0 and this equal to 0. This both the coefficients are 0. So you have a equal to half from these last two relations, this left hand side and right hand side. Because lambda is a double root, so it will satisfy this equal to 0, this equal to 0, and finally you have a equal to half. This is the way to calculate by the method of undetermined coefficient and get the value of the undetermined coefficient. Okay. So let's have the working rule. How will you? So there is a series of charts here. So I am considering d2y dx2 plus 8 second order. Mainly I am considering second order, and these results can be extended to higher order also. So when the equation is given in the form d2y dx2 plus 8 dy dx plus by equal to rx, this is equation 1. Then the complete primitive of 1 is y equal to ca plus ypx, where ypx is any particular solution of the given equation, right? Now, if rx, that is your right hand side, rx, it depends on the rx. Rx is an exponential function, e to the power lambda x. Then what will be the form of the particular integral? This is the chart showing the forms. So the condition is if lambda is not a root of the auxiliary equation, then your yp will be ypx equal to a e to the power lambda x. Just we explain this example with an example how to deal with the problems of undetermined coefficients. Number 2, if lambda is a simple root, look at that, if lambda is a simple root or multiplicity 1 of the auxiliary equation, this, then your yp will be ax e to the power lambda x. If lambda is a double root of the auxiliary equation, then your yp will be ax squared e to the power lambda x. So these are the cases. If your right hand side is an exponential function, there may be constant with the exponential function, no problem, you have to deal with that, the similar process. So if lambda is not a root, your yp will be a e to the power lambda x. If lambda is a simple root, your yp will be ax e to the power lambda x. If lambda is a double root, your yp will be ax squared e to the power lambda x. Now let's try with an example. This is the differential equation, second order differential equation with constant coefficient, linear differential equation. And look at that, your Rx is this one. This is your Rx, right? Now your auxiliary equation is m square minus m minus 6. You easily verified, and minus 2 is and your Rx is this. And you can easily verify that minus 2 is a simple root of the auxiliary equation, right? So you Rx have e to the power minus 2x. So lambda is a simple root of the auxiliary equation. So go to the chart. If lambda is a simple root of the auxiliary equation, then your yp will be of the form ax e to the power lambda x, right? So your yp will be ax e to the power minus 2x, right? Now substituting this in, since yp is a solution of this given differential equation, so it will be d2yp dx2 minus dyp dx minus 6yp equal to 20 to the minus 22x. So if you substitute in this, you will have, we have after simplification and comparing, you have a equal to minus 4. So your yp of the given differential equation is yp equal to minus 4x e to the power minus 2x. That is your answer. And your complete primitive will be cf y equal to cf plus pi yp, right? Ypx. So this is your complete solution. Now let us go to the next rule. If Rx is an nth degree polynomial in X, so yeah, if I'm talking about the polynomial, maybe your right hand side is a constant or linear polynomial or quadratic polynomial or nth degree polynomial. So let's come to the rule. Number one, if 0 is not a root of the auxiliary equation, then your yp will be simple. You can assume it as a polynomial in x to the power n, a naught plus a1x plus a2x square, etc. an xn. Number two, if 0 is a simple root of the auxiliary equation, if it is a simple root of multiplicity 1, so your yp will be just the previous, but you have a multiplication with x times the quadratic, right? And number three, if 0 is a double root, you look at that, 0 is a double root, then your yp will be x squared and the polynomial in x, the whole thing. So if 0 is not a root of the auxiliary equation, your yp will be simple polynomial of nth degree. If your Rx is nth degree, if your Rx is a quadratic, then it must be a quadratic. If your Rx is a cubic, it must be a cubic. And if 0 is a simple root of the auxiliary equation, then yp equal to x times the polynomial, nth degree polynomial. And third case and the last one, if 0 is a double root, then yp will be x squared and the nth degree polynomial. Okay, let's have a problem on that. Look at that. You have a second degree linear differential equation and your Rx is 4x squared. It's a quadratic polynomial, right? Maybe all other terms of 0, that is not required here, but you have a highest power x square, so it is a quadratic polynomial. And the auxiliary equation is given by m square minus 3m plus 2. So your Rx is 4x square and 0 is not a root of the auxiliary equation. You checked that 0 is not a 0, doesn't satisfy the equation, right? Therefore, we choose the pi in the form, look at that pi or yp as a quadratic because you have a quadratic Rx. So your polynomial will be in quadratic polynomial, a naught plus a1x plus a2x squared. And yp is a solution, particular solution of the given differential equation, so it will satisfy the equation. So your substitute in this equation and simplify and equating the coefficients of different powers of x from both sides. You have to, after substitution and calculation, you have to equate the coefficients of different powers of x from both sides. So we have this system. So you are equating the coefficient of x square, you are equating the coefficient of x, you are equating the constant term. You have the system of equations. 2a2 equal to 4, 2a1 minus 6a2 equal to 0, 2a0 minus 3a1 plus 2a2 equal to 0. Right? Solving the above system, we obtain a2 equal to 2, a1 equal to 6, a0 equal to 7. If you solve, you will get this type of result. So your particular integral pi is given by yp equal to 7 plus 6x plus 2x square. And your final solution, that is the complete primitive, equal to cf plus yp. Okay, got it? So this is the thing. So this is how you have to deal with the problems of undetermined coefficients if you have quadratic. Let's move to the next rule. If Rx is a sine and cosine function of x. So if Rx is a sine and cosine function, suppose you have k1 cos lambda x plus k2 sine lambda x. Then in the first case, if plus minus I lambda are not the roots of the auxiliary equation, then your yp will be a cos lambda x plus b sine lambda x, right? Just in the form of the Rx. You have to assume in the form of the Rx. But if plus minus I lambda are the roots of the auxiliary equation, then your yp will be x times a cos lambda x plus b sine lambda x. So this is the rule. So let's have a problem. Suppose this is a linear differential equation and Rx is d2y dx2 plus 2 dy dx plus 4y, and Rx is given by cos 4x. And your auxiliary equation is m square plus 2m plus 4 equal to 0. So you can easily check that your m roots are m equal to minus 1 plus minus I root 3. So you see that plus minus 4i, because cos 4x has 4x. So plus minus 4i are not the roots of the auxiliary equation. Plus minus 4i are not the roots of the auxiliary equation. Therefore, we choose a pi of the form. You have to choose the pi of the form similar to your Rx. So you have to choose like yp as a cos 4x plus b sine 4x, right? And ab are the constants. Now yp is a solution of the given differential equation as previous. So you have to substitute in this result in this differential equation that is satisfied by yp, calculation, and equating the coefficients of cos 4x and sin 4x from both sides. You have to equate the coefficients of cos 4x and sin 4x from both sides. We have the system of equations. 4 times minus 3a plus twice b equal to 1, 2a plus 3b equal to. So you have to equate the coefficient of cos and sine. And this is simultaneous. You have to solve. And solving, you will get b equal to 1 by 26 and a equal to minus 3 by 52. You can verify the result also by yourself. So finally, you will get the yp as 1 by 52, 2 sine 4x minus 3 cos 4x. And you can write the complete primitive y equal to ca plus yp. So this is how you can deal with the problems of Rx if Rx is a sine or cosine function of x. Next, suppose if Rx is a product of the exponential function, it's a combination of different functions. Suppose Rx is a combination of product of the exponential function with a polynomial function. So you see Rx is a product of e to the power lambda x and the polynomial, right? So your yp will be, if lambda is not a root of the auxiliary equation, so your yp will be simply like your Rx. So e to the power lambda x and times the polynomial. This is first one. Next, if lambda is a simple root of the auxiliary equation, so in that case, your yp will be x times, x is multiplied with the previous result, previous yp. So x times e to the power lambda x and the polynomial times the polynomial. And if lambda is a double root, if lambda is a double root of the auxiliary equation, then you have yp is x squared times the first one, that is another x is multiplied, so you have a x squared e to the power lambda x times the polynomial. So these are the cases, and this is the table for your better understanding that if Rx is a product of exponential and the polynomials. So now let's have solved the problem. If d2y dx2 minus 2 dy dx plus y equal to x e to the power x, look at that. Your Rx is a product of exponential and the polynomial. It's a linear polynomial. So and the auxiliary equation is m square minus 2m plus 1 equal to 0, and you can easily check that m equal to 1 1 are the solutions or the roots of the auxiliary equation. So 1 is a double root of the auxiliary equation. So in this case, what you have to assume, your pi will be in the form x squared e to the power x a naught plus a1x, because you have a linear polynomial. For x, you have to choose a naught plus a1x, right? And exponential function is exponential function, but you have a double root here, so you have to write x squared. 1 is a double root because e to the power lambda x, lambda is 1. And again, yp is a root solution of the given differential equation. So you substitute, calculate, lot of calculations, and equating the coefficients of x and the constant term from both sides, we get this type of the coefficients. So a naught equal to 0 and a1 equal to 1 by 6. So finally you will get the yp, the particular integral of the differential equation, 1/6 x cube e to the power x. That will be the solution of the differential equation. Okay, so I told you the main concept of linear. If it is a combination of the functions, there won't be any problem because I gave you the example with a clear explanation. And next, let's see, let's table. I will explain the next table also. Yeah, if your Rx is a product of the exponential function and sine cosine function, so if alpha plus minus I lambda are not the roots of the auxiliary equation, then your yp will be same as the Rx, you have to assume, but the constants will be different, a and b. And if alpha plus minus I lambda are the roots of the auxiliary equation, then it will be x e to the power alpha x a cos lambda x plus b sin lambda x. So x is multiplied with the previous case. So in this case also, you can deal with the problems of differential equations having the product of exponential and sine cosine. So you I think you don't have any problem with that, dealing with those problems. And if Rx is a product of polynomial with a sine cosine functions, so look at that, you have a sine cosine function and the polynomial. So in this case, if I plus minus I lambda are the not the roots of the auxiliary equation, then your yp will be of the form cos p lambda x. It will be much complicated one. This is much complicated. If you have a cosine function and the polynomials, then it will be much more because a lot of constants are involved. So it will be cos lambda x into polynomial in x, a naught a1 an, and plus sin lambda x b naught b1 bn. So in the second case, if plus minus I lambda are the roots of the auxiliary equation, then your yp will be x cos lambda x times the polynomial in n and x sin lambda x times the polynomial in n. So you have the 2n constants, a naught a1 an and b naught b1 bn. So a lot of constants are involved. So another one, I think this is the last type. If you have a 3 types of functions, this is much more complicated one. If Rx is a product of an exponential function, a polynomial function with a sine cosine function of x. Okay, so you have a exponential, sine cosine, and the quadratic. So look at that. If alpha plus minus I lambda are not the roots of the auxiliary, then you have a simple case. So e to the power alpha x cos lambda x and the quadratic and the polynomial in x, and plus e to the power alpha x sin lambda x and the polynomial in x. But if alpha plus minus I lambda are the roots of the auxiliary equation, then yp will be x e to the power alpha x. There is a x multiplied in the previous case. Previous case will be multiplied with x. That will be the second case if alpha plus minus I lambda are the roots of the auxiliary equation. So there is a concept of sequential concept. So these are the basic tables for calculations of the undetermined coefficients. So these results will be very useful, and you have these results are presented in front of you. I think it will be very handy for you. You can get the solution very quickly. So let's have the generalize the concept. If you have nth kth multiplicity of, suppose you have higher order derivatives also, so these results are for higher order derivatives, not second order. It can be more than second order, so it will be third order differential equation, fourth order differential equation, or nth order differential equation. So if you have a lambda is a root of the k multiplicity k, then you have this type of result. So those results are actually generalized. We generalize the concept of the previous results. So look at that. In this case also, if Rx is a nth degree polynomial, then these results are also x to the power k, because you are using more than second order derivatives. So you have more than second order derivatives are involved. You can generalize your concept. So this is the generalization of the previous concepts. Okay. Sine cosine also. For sine cosine also, we are generalizing the concept. And if there is a product of exponential function, polynomial function, look at that, x to the power k, if lambda is a root of the auxiliary equation with multiplicity k. In this case also, we have generalized the concept for higher order derivatives of linear equations. Rx is a product of an exponential function with sine cosine functions. Okay. And Rx is a product of the polynomial with sine cosine functions, right? So here also we are observing the same generalization. It's the same process, same formulae, but you are what happened? You are taking the higher order derivatives, not second order, and the product of all three. Okay. So this, in this case also, you have x to the power k multiplied, because you are considering alpha plus minus I lambda are the roots of multiplicity k, complex roots of multiplicity k. So that's all about your undetermined coefficient. This is another method for finding the particular integral. If nothing is mentioned in the question what you have to do with the particular integral, then you can do by d operator method, or by variation of parameters, or by method of undetermined coefficient. So you have three choices. And if the equation is of Euler homogeneous, then you can take advantage of x equal to e to the power t substitution. So there is a long discussions in the finding the particular integral today. Okay, hopefully this video will be helpful to you. Thank you all of you for subscribing my channel. So you follow my channel and follow my videos. Thank you all of you.